Okay, let's do this problem. Okay, and this is what this problem. Let me see if I can put it bigger. I don't think so. No, this problem is telling you, okay, that this is not easy to understand. Okay, but if you got ethanol, right? C2, let's start. C2, C2H, well, C2H5OH. Um, um, is used to make diethyl ether, okay, which is gonna be C1, 2, 3, 4. I'm doing this because of the molar mass. 1, 2, 3, 4. Hydrogen, we have 10, I think, if I remember correctly. 7, yes, 10. And then oxygen, we have 1. Now, hold on for a second because I think I have this numbers done already, so I don't need to be calculated and it's going to be fast. Yeah, I do. So, we're going to do here, right? In a side reaction, some ethanol forms ethylene and water. Okay, now let's look at the first question. If 52 grams of ethanol yields 26 grams of diethyl ether, what is the percentage of yield of diethyl ether? What do you think is this? This is the actual yield, okay? This is the actual yield. And in other words, they're telling you that part of these 52 grams are going to be converted to ethylene and other side products. So you have to be able to calculate, right? How much are you supposed to get if all the ethanol reacted, all the 52 formed diethyl ether, and if not, if only 26.6 were produced, how much is that percentage? How much is the percentage of ethanol that was converted, was that formed the ethyl ether? So you do it as any as stoichiometry. And you do, okay, you have the 52.7 grams of ethanol. What is the first thing you're going to do? You're going to use the equation to do the mole ratio because what you want to determine is the mole of diethyl ether. And so you need to find out the moles of ethanol. Again, we do the flow chart and everything. But as I have already the calculation, this is 46.07 grams per moles. So you divide, and this is gonna give you, what I don't have is this, 52.7 divided by 46.07 equals 1.1439 moles. Okay, so you get this, right? So now, what are you going to determine? Well, with this mole, 1.1439, you're going to tell me how many moles and then how many grams you're supposed to get. If all the ethanol, the 52, are reacting, all the 1.1439. So 2 of ethanol moles of C2H5OH, right, produces 1 mole of C4H10O. If you have 114, which is the 50 grams, moles of C2H5OH, cancels out, cancels out. How many moles will you be producing of ether? And that is going to give us again 1.1439 moles by 1, right? Moles of C4H10, and then we divide it by 2. And that is giving us 0.56 moles. Now you have to convert it to to grams, because you have to compare it to the grams of to the 26 to get the percentage of yield. So the grams of the C4H10 of the diethyl ether O is equal to 57.196 moles. We multiply by the molar mass that I'm going to tell you right away, which is 74.12. Just calculate it for yourself. But it's 74.12 grams per moles. And this is going to give us 42.3934 moles. And this is, keep the decimals yet, okay, don't round it. Now, how do we calculate the percentage of yield? Of course, we divide the 26, that's what we really get, the actual. We divide it by the 42. So the 26.6 gram would be the actual yield, right? Divided by 42.3934. This is, by the way, this is grams, sorry. By 100, and it gives you exactly 62. And by the way, I asked for 2 decimals. That's around 62.75%. That was the number exactly. Now you got the part A. Now listen to the part B and read it. It says if 52.7 grams, part B, during the process, 45% of the dead ethanol that did not produce the ethyl ether reacts the side reaction. What mass of ethylene is produced? Of course, now we got the second one, but we need the moles of ethanol that did not react. Are we going to get a 45% of 52.7? No, because a 45% of 52.7 would say a 45% of all the ethanol, of the initial amount of ethanol. It said the 45% that did not produce. So what do we have to do? We have to calculate the amount that didn't react from the 52.7 and then get a 45% of that. So if you know already that what reacted, okay, if you know already that what actually you got was 60 grams per 6 of the ethyl ether, you cannot go anyway because you don't have an idea yet how much of that ethanol really reacts. You have 52 initially and 1.1439, but you don't have, the only thing you have is the percentage of yield and, right? And in other words, with the 52, you're supposed to get 42.39, but you got almost a half. So that means that approximately you're going to have a half of methanol that didn't form the ethyl ether. So what is the best way of doing it? Best way is we're doing now the opposite. And the opposite would be, we don't need to calculate. There's two ways. One way would be, okay, let's calculate what really reacted. My way of doing it is, okay, how many moles are 26 point, how many moles of the ethyl ether are 26.6 grams? That's the way I would do it, because if I subtract it here, then it's going to be more confusing. So, because I'm subtracting the ethyl ether, okay? So what the first thing you have to do? You have to find out, well, first, the grams of the C4H10O10O. And just to, let me see if I can copy. I don't think I can copy this. No. So you had to go back, right? So the moles of C4H10 would be, again, what you produce. Okay, the actual yield, 26.6, right, grams. And then the moles would be divided by the molar mass. Yes, you had to go back, unfortunately, again, to be able to compare methanol, because if not, it's like one of the students was telling me, but that's the ethyl ether. Yes, I know. It has to be ethanol. So you have to go back. So 26.6 gram divided by the molar mass, which is 74.12 grams per moles. And that gives me, I don't have the moles here. No, I had to because it's done directly and I like to do it in separate. And divided by 74.12 is gonna be 0. That's really the amount of moles of the ethyl ether that you got. So it's gonna be 0.358877496 or 0.35, let me not exaggerate, 88 moles. Of what? Of the diethyl ether, C4H10O. Now we have to go back to the chemical reaction. Why did I find out the moles? Because we had to go back to ethanol, here, from here. So now what we're going to say is, okay, now really, really what I got was 0.3 0.35888 0.35888. How many moles of ethanol then is really reacting? And how do you 2 over x and 1 over 0.33? So now you have to multiply by 2. So 2 moles of C2H5OH. You want to determine how many really react. 0.35888. By the way, but I want to finish that video. I don't know how I'm going to get there. It's already 12 o'clock, but I'm going to finish it. So it's going to be, this is going to be 1 mole. Okay, because it's the equation. That's why I like to carry my equation everywhere. You see it's 1. It's a 2 to 1 ratio, remember? So it's 1 mole of C4H10O divided by 0.35888 moles of C4H10O. So this and this cancels out. Now X up, this up. Now we have to do the opposite. So it's going to be by 2. And I'm going to give you directly the results. And it's going to be 0.717754999 of moles. Okay, 0.71775 moles. Now, you have two options here. Yeah, either you subtract the 2 moles because you already got the moles of 52 grams, right? It was 114. Or you convert this and then you convert it to grams. Or you convert these moles multiplying by 46.07, that is the mole mass of the alcohol, of the ethanol. So you got here, right? 0.71, and then you subtract from 52. 0.77 moles, we multiply by the molar mass of the ethanol, of the C2H5OH. So this is going to give us 0.71775 moles multiplied by 46.07. That's the molar mass of ethanol, grams per mole. So to get the grams. And this is going to give us 2.2 I think it's right. 6.07 is gonna be okay. Yeah, I know what happened because they solve it like I did in the quiz and when we were solving the class. uh, what that is, okay, what the mass of the ethyl ether, that's what the student was taught, because you can either solve it like I'm doing it now, or you simple, what you can do is like if you know the 42 where you're supposed to get and you got only 26 grams of the ethyl ether, you subtract it at that initially the ethyl ether, and then you know the amount of grams of the ethyl ether that didn't form, and then you go back and convert it to mostly ethanol. I'm doing it the other way. I'm crossing my fingers that it should give you the same. There's no way it's gonna give you different. So it's 2.941 grams of of C2H5OH. So it's gonna be, how many grams did you had in we had initially of methanol? 52.7 minus 2.941. I'm seeing that it's not gonna give me. I'm gonna stop the video and see for one thing what was my mistake here. I'm glad you didn't hear me. I forgot the microphone again. It's 71 here what I was making. If I don't know if you noticed, I was making a mistake here multiplying this two and it's 33. So if we got initially we got 52 grams of ethanol and 33 became or were converted into react to form diethyl ether. So that means that what is left over 19.663 grams of ethanol, because if you look at the reaction here, right? You know that if you got 52, right? If you form 26, you subtract the amount, but you form 26, so you need to convert that, go back to convert it to ethanol, and that gave me 33 grams of ethanol. So 33 grams of ethanol are gonna be converted to the ethyl ether. What happened with the rest? Well, 52.7 minus 33, then it gives me 19.623 that didn't form C4H, the ether, H10O. Now, if you read the question, the letter B, it says 45% of that didn't react, of the ethanol that did not produce the ethyl ether. What is the amount that didn't produce 19 grams? So a 45% of 19 grams. So it's going to be 19.633, 19.663 grams, and a 45.45% gives me the grams of ethanol gonna be 8.8 grams of ethanol that form the ethylene. That means what I'm saying is that from those 19 grams that didn't form the diethyl ether, C4H10O, there's only a 45% form ethylene. So it's going to be 19 grams are going to form the C4H10O. Then 8.835 are going to form ethylene. The rest, throw to the garbage. It doesn't say in the problem. So everything have to be equal to 52. So if you add 8.8, 19.633, well, it doesn't matter how much, just subtract it. That gives me, have to give me everything total to 52, the 3. So now we know the grams of ethanol. So now we have to divide it by 46 to convert it to, because what is the question on B? All that to get to here. During the what mass of ethylene is produced? Well, you're going to do the same thing. One 1 mole of C2H5OH. This is the ethanol, right? Again, we have that. We have to calculate it. And this would be 1 mole. It's a 1-to-1 ratio. And if we have it, it's a 1-to-1 ratio. So that means that the grams of ethanol, we have to convert it to moles. So the moles of ethanol that reacted to form ethylene is going to be 8.835 grams divided by the molar mass of ethanol, 46.07 grams per mole. And that gives me 0.19177, right, moles of ethanol, which is going to be the same as ethylene. Moles of C2H5OH, which is going to be the same as the moles of ethylene. C2H4. Not looking at the molar mass, that is directly. So what did you do to find out the grams? Grams would be the moles of C2H4, that is the same, 0.19177 moles, multiplied by the molar mass of ethylene, and it's going to be 28.05 grams per moles. And that is going to give me the answer that we want. And that is going to give me equal 5.379, 5.379, of course, 3 sig grams, so it's 538, and that was the answer. And a lot of you were not able to get it. Okay, so finally, let's do the last one. And the last one is hemoglobin protein. It's very easy. But now I said if you have the concepts in your hands, not because I'm chem chemist, it's because if you have the concept stronger enough, you're able to do it. So don't get scared. A protein in red blood cells carries O2 from the lungs to the body cells. Iron, F as F2, makes up a 0.33 mass percent of hemoglobin. If the molar mass of hemoglobin is 6.8 by 10 to the fourth grams per moles, how many iron F2 are in one molecule? Well, I don't know if you remember that the percentage of composition of the iron, for example, here would be the number of irons, right, multiplied by the molar mass of iron, 55.845 grams per moles, and then you divide it by the whole molar mass of the compound, and that's the percentage of composition of each one. That's what I'm saying. If you remember the concept of percentage of composition, you wouldn't have too much of a problem, right? I wonder where is it. Okay, so you divide it by the total molar mass of the compound, and in this case hemoglobin, by 100. Now, you don't have the number of iron. That's what we're trying to find out. But they're giving you this, the molar mass of the hemoglobin, which is 6.8 by 10 to the fourth. They're giving you the percentage. That is a 0.33%. So if you do 0.33%, and you don't know it yet, that's what you're trying to find out, multiplied by 58.845 by 100, and 6.8 by 10 to the fourth, So now we're going to do something interesting. Let's multiply both sides by 6.8. So it's going to be 0.33 by 6.8 by 10 to the fourth divided by 100. And let's leave this on this side yet. 55.845. In other words, you get a 0.33% of the whole molar mass, right? And you divide it by the mass, molar mass of Fe, and you get the number of moles of Fe you have. So it's gonna be 0.33 by 6.8 divided by 100 gives me 0.0 by 10 to the fourth. So it's gonna be 0.02244 by 10 to the fourth equals n by 55.845 grams per moles. Sorry, this is grams per moles too. And this, remember, was grams per moles and grams per moles and grams per moles. GM I'm gonna put. So 1, 2, 3, 4. So it's gonna give you 220. Let's see, 1, 2, 3, 4. Yeah, 224.4, right? Equals to n. Now do me a favor. Just divide 224.4 by this. Grams per moles and grams per moles cancel out, and you should be able to get, right, the number of molecules. So 2 point number of atoms of iron divided by 55.845 equals n. You divide this by 55.845. Oops, 40.401. So the number of Fe atoms in a hemoglobin molecule is gonna be 4.018, which we rounded to 4. And this is the answer, and this is the end of the quiz. Bye bye, good night, and I'll be posting tomorrow. I guess I'm posting this waiting for some of the students. What I'm probably gonna do, make another quiz for them, but because I want to start posting this for you guys, and tomorrow the practice exam should be on, and basically the video I'm gonna be trying to do it before Monday, if I can. Okay,